So welcome back, guys. We are going to start with our next chapter, which will be on IPv4 addresses. So let us begin. Okay. So before moving on to the IPv4 addresses, let us discuss what is IP address. So what is the meaning of IP address? So IP address is nothing. It's just an identifier. So uh, what is the meaning of address? Address is, let's suppose, the address of my home. So address of my home is an identifier for a particular home in a particular area. So let's suppose if I have a whole area, and let me give this area as ABC. Then there are certain homes that will be there, certain houses. Okay, so each house will have a specific designated address, and that is what is similar to the in our network, computer networks as well. So each home, each house that we have in our ABC area can be considered as a device. Okay, and this ABC area is can be considered as a network. Okay, so it is an identifier for a particular device that is connected to the internet. I hope it makes sense. Okay. Now, when I talk about IP addresses, then there are two protocols. So when I talk about that, it identifies for a particular device that is connected to the internet, then it is it is a unique identifier which works on network layer, or we also call it as IP layer. Okay, there are two protocols which uses IP addresses. There's IPv4 and the second one is IPv6. Okay, moving on, in this chapter we are going to just focus on IPv4 protocol. So let us begin. Okay, so what is the meaning of IPv4 address? So IPv4 is actually a protocol, and the addresses that are defined in IPv4 is actually the addresses or the devices that can be connected to the internet at a particular time. So IPv4 protocol says that the size of that the address could be 32 bits. So the size of a particular address will be 32 bits as per the IPv4 protocol, and the IPv4 address will uniquely and universally identify a device that is connected to the internet. So what is the meaning of unique and universal will become clear. So the meaning of unique is that in this sense, the unique means that for a particular connection, there will be a specific address. So one connection will have one address, one IPv4 address. And universal means that so two devices, let's suppose there are two devices that are connected to the internet. So two devices that are connected to the internet. So both of these devices will have different IP address. They cannot have the same IP address at the same time. So they will always have unique or different IP address for both the devices that are connected to the internet. So it is possible that, let's suppose, if I have one device as A and the second as B, then at some time the address of A is 2.3.4.5 and the address of B is 4.5.6.7. So it's not possible that both the devices that are connected to the internet will have the same IP address. Let's suppose after some time the IP address could be reversed. It is possible that the B could have 4.5.6.7 or A could have 2.3.4.5. It's not possible that both of them will be equal. It's not possible. So that is the definition of IPv4 universal in nature. And the universal definition also says that there is one more point that I would like to add, that let's suppose if I have one device and it is connected to the internet using two connections, then both of these connections will have different IPv4 addresses. So let's suppose if this connection, if this is my device, and this is connection number 1 and this is connection number 2, then this will be IPv4 address 1 and this will be IPv4 address 2. So that is the meaning of unique, universal in nature. Moving on, there's next term that I would like to discuss, which is called as address space. Okay, now what is the meaning of address space? So address space is actually the number of addresses that are used by the protocol. So in our case, that protocol, which is IPv4, IPv4, it actually its size is 32 bits. So if let's suppose if I have a protocol which the size of that protocol is b bits, then the address space for that particular protocol will be 2 to the power b. And how this 2 will come, let me give you an example. So in when I talk about computer, then there are only two digits that the computer understand, which is 0 or 1. So out of those two possibilities, I can have any number of combinations with b bits. So that is 2 to the power b addresses that are possible for any protocol. So if I talk about IPv4 protocol, then its size is 32 bits. So the address space for or the number of addresses that are possible in IPv4 protocol is actually 2 to the power 32 addresses. Okay, so what is the meaning of IP address space is you can understand in such a way that suppose if theoretically if there are 2 to the power 32 devices that are connected to the internet. So theoretically, if there are no restrictions, there can be 2 to the power 32 devices, which are approximately equal to more than 4 billion. So approximately more than 4 billion devices could be connected to the internet at the same time. So that is the meaning of if theoretically that were the case, like if there were no restrictions. However, there are certain restrictions in the addressing as well, which we'll see in a later part. So it says that more than 4 billion devices could be connected to the internet at the same time. So that is the case of address space. Now moving on, we'll discuss about the notations part. So this will be all for this video. Thank you for watching.